All right, 3.3 logarithmic functions. And their graphs. We're not really doing anything with the graphs of them because your calculator does that for you, but just solving them. We'll be doing a bunch of those. So 2, I've got log base 6 of 1. So this is just a property that you should have. And so if we have log base b of 1, what does that equal to?
6.
0. Because if we did this like this, then we would use an e to solve. 6 to the x is equal to 1, and so we would know that it has to be 0. So this is 0. 4, log base 3 of 81. So we can either think about this as 3 to what power is equal to 81, or can I rewrite 81 in terms of 3?
Yes.
Yes, I can. I can call this log base 3 of 3 to the 4th. Then this is just a property, log base 3 of 3. It's equal to whatever the exponent is, so this would be equal to 4.
Can you do that with all of them, or like what we did for number 1? Can I use that on every problem?
Anything that's a log base something of 1, you can, because that's a property that's in the notes.
I can't do like log 380. I can't do the e for the log 381.
What do you mean?
But can I just do 3 to the x equals 81 instead?
Yes.
Okay.
Yes.
I just want to make sure because I don't want to have 3 different ways to solve it and then I don't remember any of them.
All right. 6. Log base 6 of 1 over the 5th root of 36. All right, so this is one where I technically can use the method that I just used in 4. However, probably aren't going to see that right away. So I would use the e method on this one. So set it equal to x and then loop it around this way so that I have 6 to the x is equal to 1 over the 5th root of 36. But is there a way that I can rewrite 1 over the 5th root of 36 maybe in terms of 6? Because ideally what I want is I want them to have the same base so that then the exponents are equal to each other. So is there a way that I can write 1 over the 5th root of 36 as 6 to some power?
6 to the negative 5th. 6 to the negative 2 over 5.
Yep. So this 36 is really just 6 squared, right? So I could think about this as 1 over 6 to the 2/5. But I need that on top, so to move that up, we have to change the exponent. So what I end up with is 6 to the x is equal to 6 to the negative 2/5. If they have the same base, then their exponents have to be the same. So that means x is equal to negative 2/5, which is the answer to that problem.
I thought it was 5 times root of 36.
8. Log of 10,000. All right, so what base is on this log?
0.
10. It's common log, so it's base 10. Can I rewrite 10,000 in terms of 10?
10 times 10 to
How many zeros are there?
3.
So 10 to the 4th. So this is log base 10. Okay, we don't normally write it, but I'm doing it so we can see it. So we can use the property. If it's log base of some number, okay, that are the same, then it's equal to the exponent. So this is equal to 4. You could still do the 10 raised to the x is equal to 10,000 and do it that way. Also, up to you. I'm trying to show you two different methods because this uses properties. The other option is just general solving. Because technically these aren't really solving for x. We're putting an x there if we're going to solve them out like that. 10 log of 10 to the negative 4. What's this equal to?
Negative 1.
Negative 4. Just a
It's
property.
common log.
These are properties that are in your notes.
Shepherd to do notes.
No, I'm saying.
I know.
So since it's raised to the negative 4th, that's basically saying the 4th. Is that saying the 4th root of 10, or is it saying?
No, it's the power of 4. It's negative because it's on top.
Oh, so like it's actually written as 1 over 10 to the 4th.
I mean, if I was going to do that, then yes, but that's not at all what it's asking me to do.
Oh.
I'm evaluating the logs. Technically, I shouldn't even be writing equal to x. I'm just doing that for some of them because it's easier to see what's happening. These are all just using properties. 14. ln of e to the negative 4. What base is this log?
Natural log.
Okay, it's a natural log, so that means it's base e. So what is this equal to?
Negative 4.
Yep. Log base e of e to the negative 4. Stuff cancels out until we get negative 4. 16. The ln of 1. What would that be equal to? 0.
Why?
Because it's a property.
Because if you draw the L, then you can do that thing.
It's just a property. You should just know that. You shouldn't even have to look at it anything other than a log of 1 is equal to 0. An ln of 1 is equal to 0. Anytime it's of 1, it's got to be equal to 0 because that's the only way that works. It's a property that you just have to know. 18. ln of 1 over the square root of e to the 7. How might I need to rewrite this?
Square it.
No.
E to the negative 7. No, e to the negative 2 over 7.
It's a negative 7 over 2.
Negative 7 over 2. ln of e to the negative 7 over 2. The power goes on top. The root goes on the bottom. This was in the denominator, so I make it negative. So now what is this equal to?
Negative 7.
Negative 7 over 2.
Negative 7 over 2. Evaluate the expression, and all these are without a calculator. So 20. 5 raised to the log base 5 of 8. This is another property that you have.
Log base 5 equals log base 5, 8.
Nope. It's property 4 in your notes. Somebody look it up.
8.
Is equal to 8. 5 raised to the log base 5, those things undo each other. Logs and exponentials undo each other. So if this has the same base here, then it's just equal to whatever's in here. 22. 10 to the log of 14. 14. 24. e to the ln of 1 over 5. Should be the easiest section we've done all year. All right, something that may or may not have been in your notes, I'm not sure just because of where it is on my paper, but we can't have negative numbers or 0 inside the log.
Yo, I can still write it if it's in my notes.
Facts.
I'm writing.
Me too.
If there is, then it is undefined. All right, so the next ones do want you to use your calculator, so grab your calculators. These are all using your log buttons directly on your calculator, not your log base buttons. So 26, the log of 0.908, and these specifically say use your calculator to evaluate the logarithmic expression if it's defined, and then it says to check, but I'll show you how to check it, but we don't really have to do that. Okay, so you just hit the log button and then 0.908 and then equals negative 0.0419. Now, if you want to check it to make sure that you did it right, if you think you might have typed something in wrong or whatever, this is a common log, so raise 10 to the negative 0.0419, and it should be equal to 0.908. Now, if this is a rounded number, it might be slightly off, but it should be close enough. Somebody raised 10 to the negative 0.0419. 0.908 equals 0.908. So then you know you've done it correctly. I don't care if you check them, but that's how you would check them if you need to. Now, 28. Log of negative 5.14. All right, so it is undefined, but I want you to see what happens if you type it in your calculator. Type in log, use the little negative sign of 5.14, and tell me what it says.
Non-real answer. Domain error.
Yep, domain error, non-real answer, something like that is going to come up, okay? So that would be your cue when you come ask me, why is my calculator not working? I'm going to be like, think about it, okay? Because that's what that means if that's coming up like that. $30. ln of 0.733. So this time you use your ln button and then type that in. Tell me what we get.
Negative 0.311.
Negative 0.311.
Jeremy, why is your art project like a Chinatown?
It's a China person. It's like Wushilaki Ting Tang or something, whoever drew it. I forget his name.
All right, the last problems of this section say to solve the equation by changing it to an exponential. So 34, log of x is equal to 4. So now I'm trying to solve for x. To do that, it says change it to an exponential. So even if you know what this is equal to, like already just looking at it using the properties, you have to change to an exponential because that's what it says to do first. So to do that, we start at the base. I'll move the whole thing. We come around like this. So I have 10 raised to the 4 equals x. This is why I said in the last section, I was like, they should really bump that section to after this one so that you've done this. But so then 10 to the 4th is
10,000.
Zach knows it now. 10,000 is equal to x. Now, technically, if you left it as 10 to the 4th, it would still be right, but they want the actual number. 36, log of x is equal to negative 3. So we do the same thing. We start down here, loop around. So I've got 10 to the negative 3 is equal to x.
Which is
10 to the negative 3 would be what?
1 over 1,000.
1 over 1,000 or 0.001.
That's what
Either of these would be acceptable. And that's pretty much it in this section. Are there any questions?
no.
All right, on those first 17 problems, well, actually 24 problems, there's no calculator. Okay? So, get used to using your properties and all the things because we may have a no calculator page on the quiz so that I can ensure that we're not using it.
Did you find it?
All right.
I don't know what this is.
We are going 1 through 35 odd because you have more than enough time in their quick problems.
I think I was supposed to actually say.
Get lots of practice. What are you turning in?
I don't know, but I don't know if I did it or not, so I'm just gonna turn it in just in case.
But what is it?
3.1 homework. I just found it inside my book.
Well, at this point it would be late because it was due last like Wednesday, or we did it on Wednesday. Due
I
last.
don't have my nice little check mark that it is on.
I don't put a check mark on
I
them.
put on it
Oh.
so that I